Hi kids, today I'm going to talk to you about more ways to find equivalent fractions. Now yesterday I talked to you about the number line and how a carefully built number line is a good way to see where fractions live at the same point on the number line. So yesterday I did a model for you, or an example, where we divided the whole into thirds and also by sixths, and we discovered that fractions that look different actually have the same value and sit at the same place on the number line. So that is one way of seeing equivalent fractions, and the way we show it in another way in math without making a number line is just by saying that 1/3 equals 2/6. So they have the same value. And yesterday we mentioned it's like how 50 cents in quarters has the same value as 50 cents in dimes. 5 dimes equals 2 quarters. So 1/3 equals 2/6, or 2/3 equals 4/6. And we can see it on the number line. So that was yesterday. But today I'm going to show you another way. So this is called a fraction strip, and I want to show you that a fraction strip is a really nifty way of seeing an equivalent fraction. One of the reasons they're so cool is that they are cut and designed and made for you so that they're like perfect. So you know, when we draw our own number line, there are sometimes little mistakes. We make something be too big or too small, and our jumps aren't perfectly spaced out. Well, fraction strips are cool because they're perfectly cut. So we can see here that 1 whole is the same as 2 halves. And I kind of drew a little number line on here just to help you connect to what you saw yesterday. If I were to put a split here and just slide these away, you would see, oh, okay, so there's the halfway mark. 1 jump out of 2, that's what half is. 1 jump, and I could even do this. 2 out of 2 jumps and 0 out of 2 jumps. So I just wanted you to see that connection, that what you learned yesterday is awesome, and what you're seeing today is absolutely similar and related to what you did yesterday. It's just showing it in another way. So 2 halves is 1 whole. Okay, so I'll do a couple more examples with the fraction strip. Let's see, fourths. So if I were to divide my number line, I don't have 4/4. I have a bag that doesn't have 4/4. I'll dig out another bag. Here it is. We can see 4/4, or 4 jumps in a hole. And so your fraction strips, I'll even slide this up so you can see it. You can see that it takes 4/4 to equal 1 whole. But let's just think of this in another way. Let's just pretend we're thinking about the half. How many copies of a fourth does it take to fill a half? Well, we can see it takes 2 copies. And today in your lesson, you're going to see that they ask you about copies, and they say how many copies of an eighth does it take to fill a fourth. And so this is what they're talking about. They're thinking about fraction strips. And I know you kids don't have these at home right now, so that's why I wanted to make sure I showed you this here. And I also want to just remind you that even if you don't have a fraction strip, first of all, you could make one, but secondly, your number line serves the same purpose. So if I were to add fourths to my number line, okay, here's the first fourth, the second fourth, whoop, there's an equivalent fraction, the third fourth, and the fourth fourth. So you can see that it does take 2/4 or 2 copies of a fourth to fill in a half. So this is just another way to find equivalent fractions. And I would even write that down. 2/4 equals 1/2. So you might have to do that in your workbook today, is to maybe draw it as strips or as a number line, and then to write it in this mathematical way. 2/4 equals 1/2. Let's try one more. Let's do something different. Here, I'll just go like this. We don't need the paper. C/6. Now, because you understand the number line, if I say that we're going to use the unit fraction of sixths, you know that I'm dividing my whole into 6 parts, 6 jumps. So I have 3/6, 4/6, 5/6, and 6/6. On a number line, it would look like 5 tick marks, but 6 jumps. Jump 1, jump 2, jump 3, jump 4, jump 5, jump 6. So 6/6 in one whole. If I wanted to find out how many sixths are in a half, I would count my jumps to the halfway point. Or in this case, I can count my fraction strips. So 3/6 equals 1/2. I need a fresh piece of paper here. 3/6 equals 1/2. Or I could write it the other way. 1/2 equals 3/6. Now, one of the things I want you to start to do, kids, is to find a relationship, or look at these numbers and see what you can see. Here are some of the problems that I've shown you this morning. Let's see, we did 1/2 equaled 2/4. And we did 3/6 equals 1/2, or 1/2 equals 3/6. Let's try one more. We'll go down to tenths. So here we have 5/10, and your eyes can tell you, oh, that looks like about half of my whole, right? So let's just check that and see. Yep. So I'm going to write this last example down here, and then I want to look for some relationships. 1/2 equals 5/10. 1/2 equals 5/10. So as you're looking at these, 1/2 equals 3/6, 1/2 equals 2/4, 1/2 equals 5/10. Do you see any relationships between these fractions? What you might be seeing in some of them, I'll start with the easiest one, you might be seeing that it's like it's doubled. When we had 2/4 and 1/2, your eyes could see that there were 2 groups of a fourth, or 2 copies of a fourth in 1/2. And for me, when I start hearing groups, 2 groups of a fourth in a half, I start to think of multiplication. 2 groups of a fourth in a half. So today I want you to start to see that there's a multiplicative relationship. That's a big way of saying multiplying. And we can multiply numerators and denominators to find equivalent fractions. So let's think about what we can see with 1/2 and 3/6. for 1/2 and 3/6, we had 3 copies. We had 3 copies. And sure enough, if we were to multiply, we could see, oh, 3/6 is like 3 groups of a 1/6. So there's this multiplication relationship or connection. And over here, for this one, we did 5ths, and we needed 5/10ths. I put my tenths away already. 5/10ths were needed to equal 1/2. And there it is again, that relationship. It was 5 groups of a 1/10 were needed to build that equivalent fraction. So we had groups of 1/10ths. And I wanted you to see how this all of a sudden becomes multiplication when we're thinking about our fractions. So I don't completely expect you to understand this. I just wanted you to start to look for that relationship. Today you won't be asked to do anything like this or write anything like that. I just, as your teacher, wanted you to start to see that it is related to multiplication. When we're making groups of smaller amounts, we can find equivalent fractions. Okay, so that was kind of hard. Well, maybe not for you. The last way I want to show you how to build equivalent fractions today is by drawing a model of a figure. And this is what is going to be in your workbook. And this will probably be the part that you like the best. We can also show equivalent fractions. I'm going to try to draw 2 squares that are pretty equal in size. We can show equivalent fractions in figures or in models. So here's a really easy one that I'll try to do for you without making it too tricky. So you can see that I have shaded half of my whole. And over here, I'm going to, you know, my squares were ideally the same size. They were worth the same whole amount. But over here, I'm splitting it into 4/4. And I'm going to shade 2 of my 4/4. So even though the numbers are different, you can see that the amount that is shaded is equivalent. So this is just another way of seeing an equivalent fraction. And this is nice when someone else does the drawing, or when you're looking at something in a workbook, because they've made it congruent or perfectly worth the same value. It's not as helpful, like let's pretend you were doing a problem and you decided you were going to draw your own figure, but you didn't make them equal. You went too fast and it wasn't good. So if you split this one into 4/4 and then you split this one into I guess we could say 4/4. And then you decided to shade 1/4 of this one and 1/4 of this one. You might be confused because your drawing wasn't accurate. And you might say this one is bigger, when really it's not supposed to be bigger. You just didn't make a good drawing that had equal value, or the whole wasn't worth the same amount, because this one clearly looks bigger even though you intended to make it be equivalent. So let's just cross this off. This is the same, I guess what I'm saying too, like if you had a number line and you didn't divide it up nicely, like if you said that this was the half because you went too fast. Well, if you try to use that number line to compare fractions or to see if something's equivalent, your number line isn't going to help you because you didn't divide it into equal parts. So I guess that's what I'm getting at, is that if you're going to do your own drawing or your own number line to find an answer in math, you have to be a little bit accurate so that your drawing doesn't confuse you because you made the spaces unequal or you drew the shapes you know, so that they weren't worth the same amount. So today you've seen that you can find equivalent fractions on a number line. You can do equivalent fractions with fraction strips, and you're learning that you can use a model to see an equivalent fraction. So the last thing I'm going to do here is just show you a couple problems in your Learn book. If you want to pause your video here and get your Learn book and try these, you can. So the directions say write the shaded fraction of each figure on the blank. Then draw lines to match equivalent fractions. So this one is 1 whole and half is shaded. We could go across or down. This one is 1 whole and 2 out of the 3 parts are shaded. See, the denominator always tells you how many pieces are in your whole. The denominator, the bottom number. The numerator is the, well, in this problem, it's the shaded part. Sometimes they'll say which part is unshaded. So you have to be a good reader and a good thinker. So this one, let's see, 6 parts total. How many are shaded? 1, 2, 3, 4. Pause the video if you want to work without me giving you all the answers. I do want you to think through it too. 3 parts, 1 part shaded. Two parts shaded out of 4 total. 3 parts shaded out of 3, 6, 9 total. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 parts total. 2, 3, 4, 5, 6. 6 parts shaded. So once you've written the fraction that's represented, then you need to connect the equivalent fractions. Now this is where you start to think, what equals what? Well, right away, the first easy one, your eye can tell you, half the figure is shaded, half the figure is shaded. Oh yeah, Mrs. Crone showed us that 1/2 did equal 2/4. Now remember, kids, you know this. Oh, sorry, I just realized you can't see the bottom. There you go, my bad. You know this because of what you saw on a number line. If you divide a number line into 4 parts, there's 1/2 and there's 2/4. So your number line work should help you see these. And then again, we're looking for more equivalent fractions. Okay, so 1/3, even though they're not exactly, they don't look the same, I could imagine these boxes filling this top row, and so 1/3 is equivalent to 3/9, and I could even write it like this: 1/3 equals 3/9. And if you remember what we were talking about, we were saying, it's like you need 3 copies of this one to equal that one. 3 copies, or 3 groups of. So I'm going to stop here because that's 20 minutes. That's a long math video. I hope this helps you. Let me know if you have some questions. But have fun thinking about equivalent fractions.